Welcome to my classroom. Today we will discuss another topic, soil erosion, its causes and effects. In fact, if we define soil erosion is detachment and transport of soil particles. Detachment and transport of soil particles. So that means soil erosion is said to have taken place when the particles aggregates, they are detached, they are disintegrated, and the detached particles they are transported with running water or any type of agent. Even if animals they trample, they detach the soil particles, then they move to another place, so with the feet of animal the particles get this. So that means soil erosion basically is complete only if both the processes, detachment of soil particles and their transportation takes place. Now the question is, what are the causes of soil erosion? Why it happens? In fact, if I say that our present day soils have been formed because of soil erosion, it's a natural process, what we also call as geological erosion, because it is only because of geological erosion that the rocks these are converted into the soil, what the soils we have, what the soils we cultivate. So that disintegration of rocks into the present day soil, that is called geological erosion. But now the question is, why we should be worried about soil erosion? If it's a natural process, why we are worried? We are worried because this geological erosion, this natural process of erosion, it takes place, it gets, its speed increases when the soil particles get detached and transported at a very high speed with the rainfall, with wind, or with animals, anything, any type of the transporting agent or detachment agent, then we call it as accelerated erosion. So then it's a cause of worry, because we will see that why it's a cause of worry later on when we will study its effects. So the question is, soil erosion, as I said, it's a natural process, but when this process gets speeded up, this process gets fast, then we are worried, we call it as soil erosion. Now the main cause, the nature had protected our soils, nature has protected our rocks, nature protected hills and mountains with vegetation. So the erosion, it started from the day the man started settling at one place. It started on the day when man learned crop husbandry, when man learned animal husbandry, and due to settlements of man, he cleared, the hilly areas, or he cleared the land surface for, cultivating the land. So I should say the natural removal of natural vegetation, that is deforestation. So deforestation, which was started by man when he started settling down at one place instead of being nomad, so it is still taking place till today. Our mountains, our hills are not being spared of deforestation. And this deforestation leads to the bare soil, bare land surface. And then your agents of soil erosion, they act on it, and this is how the uh, you know soil erosion process hastens, it gets fast. Second important topic is, human population, or increasing human population. Now you might be seeing that even the agriculture lands, these are being used for non-agriculture purposes, settlements, roads, bridges. So on the other hand, our population is increasing, so we have to produce food for them. So we are compensating that land of this loss of agriculture land through deforestation we are invading the forest areas and ultimately cultivating those lands. So we call that as you know one of the reasons that because of the population our soils are getting eroded. So this is another cause of soil erosion. Then another is shifting cultivation. Shifting cultivation, it used to be a process, I should say. It was basically at one time it was a soil conservation process. That means instead of removing the forest area, instead of removing the natural vegetation, the people used to clear a part of land surface of the natural vegetation, cultivate it just for 1 or 2 years, and then abandon it, move to next part, and then there was re-emergence of the natural vegetation on the abandoned area, and then next part. So next part. This is how they moved from one place to another place. They shifted the cultivation process. They did not cultivate. So it was a very good practice that you are using the forest land for agriculture purposes, maybe 1 or 2 years, or at the most 3 years, then moving to next part. During 1 to 3 years process, because always the forest lands are very fertile, and people used to take benefit of that fertile land, and when that fertile land got nutrient with the nutrients were mined, so then they moved to next place. Then again this cultivate the land which was under cultivation, it got again converted into forest land, maybe scrub forest, or they planted trees over it, and again. So they in that way they were maintaining the forest land, at the same time they were getting the agriculture produce also. But nowadays what is happening that this shifting cultivation, once the forest land is clear, a part of the forest land is cleared, it's being cultivated over the years. Then they clear another part, it's being cultivated. So this is leading to the loss of tremendous loss of soil erosion. So the shifting cultivation, it used to be a soil conservation practice, but nowadays it's a cause of soil erosion because of its longer that duration of cultivation. Then yes, of course, harsh climate conditions. When I say harsh climate conditions, that means it could be too much of rainfall, very high intensity rainfall, very fast winds blowing, again transporting soil, detaching and transporting soil particles from one part to another part. So they similarly increasing temperatures, making the soil dry, making it more prone to when temperatures are very high, there is no water, there is no rain, the vegetation gets destroyed. This is very a unique scene, particularly in the Shivalik region or lower Himalayas. What happens that here we have the monsoon rains starting from the month of July and till September end. Or now what happens that before the onset of rainy season, it's very high temperature touching 45 even 48 degrees centigrade. So whatever vegetation it has had been there earlier, it's gone, and it's completely dry soil and bare soil, and immediately when the rains, high intensity rains come, they detach the particles and they transport the particles. So in Shivalik region of lower Himalayas, we have the soil erosion rate as high as 80 tons per hectare per year. That is huge loss. So this is how harsh climatic conditions, they also uh, are one of the causes of soil erosion. Then the another major cause is developmental activities. Like we are disturbing the natural landscape in the name of development, like roads, bridges on the mountainous areas, roads and bridges, and then dams. This is now has become very common that we harvest the river waters in dams. So when we do that, we are basically disturbing the natural landscape. Another is tunnels, making tunnels in the mountain region. That also leads to huge amount of soil loss or soil erosion in the form of mass movements, in the form of landslides. So similarly, then mining for sand, particularly mining the steep slopes, mining the most fragile areas. So that is also one of the so-called developmental activity, and it leads to soil erosion. Then, of course, increased demand for fodder. So when people they rear animals, so what happens that they don't have sufficient fodder, so they leave their animals in the forest areas, and then animals they destroy the vegetation, they consume the vegetation, natural vegetation, soils become bare, and also because of trampling by the feet of the large animals, what happens that soil particles get detached. There is no vegetation near, there is no cover, land surface cover. So when rains come, the soils are bare. So this is the best scene for soil erosion to take place. So these are some of the causes of soil erosion. Now next we will discuss about the effects of soil erosion. That why we should be worried about soil erosion, what happens due to soil erosion. So effects I can classify, one is on-site effects of soil erosion and another is off-site. So first of all, on-site. So the major, because it's a loss of soil from one place to another place, so we should say the land from which soil gets detached, transported to other parts of the land surface, so that particular land it loses its fertility. So it is loss of soil fertility because it's a surface phenomenon, and also we know that 15 centimeter or 6 inches of the surface layer, that's the most fertile one, containing huge amount of inherent nutrients. So when there is loss of the soil particles, when soil erosion is there, so those nutrients they also get lost through this soil erosion, and then our fields they lose their fertility. So similarly the structure gets destroyed, and not only the nutrients are removed along with soil particles, but soil organic carbon, that is soil organic carbon is lifeline of this soil fertility. So there is decline of soil organic matter or soil organic carbon, better word I should say, soil organic carbon. So the soils which are losing organic carbon, they are getting less fertile. Then apart from this we have destruction of soil structure. So when I say destruction of soil structure, it can be through the process of soil crusting. And I think in my previous lectures I have already discussed the effects of soil crusting and process of soil crusting. So what happens when the rain falls? It detaches the soil particles, at the same time it compacts the soil particles. So that means it is destroying its structure. Soil gets compacted. A fine compact layer, high bulk density layer is formed, which inhibits the germination, which reduces the infiltration. So that way soil loses its physical fertility. So that's why I said that it's destruction of soil structure. Then one is soil crusting. Another is, now in a particular field, soil particles they get detached, the finer particles they move with runoff water. Then on another part of this land, this field, you have a depression area. So that finer material gets deposited in the depression. So that means when it chokes that part of the depression land, it chokes the soil, infiltration reduces, and again we call it as destruction of soil physical fertility, destruction of soil structure, because if water does not infiltrate, then there will be more runoff. So this is how the soil particles from one part of the field, they get deposited in on another part of the field where you have depressions, and it chokes the soil. Choking means destruction of soil structure. Then if organic carbon depletes, nutrients gets depleted, soil structure gets destroyed, that means there is loss of soil productivity. And I'm sure that you know the difference between fertility and productivity. That means the ability of soil to produce, the agriculture products, that gets decreased because of these reasons. So then if there is loss of soil fertility, then people have to use the fertilizers, or you have to use farmyard manure. So ultimately input cost gets increased, input costs increase. So you have additional burden. The farmers, they face additional burden because of this soil erosion, because now they have to apply artificial fertilizers, synthetic fertilizers, to compensate for the loss of nutrients due to soil erosion. And yes, then this is a decrease in land value. The soil which suffers from soil erosion, the land which suffers from soil erosion, its value gets destroyed, because its value gets declined, because soil erosion is there, its productivity is less, so people don't prefer to buy such lands. And then because of this soil erosion, there could be loss of roads and bridges, particularly on hilly areas. When you have landslides, landslide basically is one form of soil erosion which happens because of the mass movement of soil under the influence of gravitational force. So when landslides happen, they destroy the roads on the hilly areas, they destroy the bridges, and it's a huge economic loss to the community. So these are some of the on-site effects. Now we will discuss the off-site effects of soil erosion. Off-site effects. Now you know that the major off-site effect is when soil erosion takes place, runoff carries away along with it the silt particles, sand particles, clay particles. So those particles, when the runoff velocity decreases, they settle down. Particularly now you assume that runoff gets built up, it enters into the river system. When it enters into the river system, and when river enters into relatively less slopy lands, its velocity decreases, and the sand particles being the heaviest, they settle down first, and then still when on the particularly on the sides of the river, on the banks of the river, the velocity is still lower, the silt particles get deposited. And when this runoff water or river water, basically river water is, it's all runoff water in technical terms, and then when its velocity becomes near zero or almost zero, then the clay particles this, that's why in lakes, when water is not moving in lakes, it gets in lakes and ponds, water gets still. So at the bottom of the lakes and ponds you will find more clay particles than silt particles or sand particles. So this process we call as sedimentation. So ultimately it will be sedimentation of rivers, sedimentation of ponds and other reservoirs. And now, you know, on how we are dependent on hydroelectricity for and for irrigation purpose also. We make big dams and we create the reservoirs on the upper side or in the catchment area. A dam is a reservoir is created. So whatever from the catchment area runoff is collected. So higher the soil erosion in catchment areas, more will be the siltation or sedimentation of the reservoir areas. So silt particles they will, and if we see particularly in India, we have majority of our dams, they have lost their dead storage because of this sedimentation. So when sedimentation is there, it is loss of the reservoir capacity. So the reservoir which was designed say for 100 years, its life gets reduced. So not only loss of reservoir capacity, but reservoir life also. So many dams they have lost their life. Their lives have been reduced because of sedimentation, and it's this sedimentation is because of soil erosion. So soil erosion is taking place at one part, and this is the off-site effect of soil erosion, the siltation. Similarly, many siltation of irrigation facilities. We have small, you know, channels created for irrigation purpose. They also get silted up. So ultimately, the siltation level is so high that the channel no more exists, and the irrigation of the fields is affected. So you have to desilt the channels every season to remove the silt particles which have come in the runoff water through soil erosion. And similarly, there is destruction of agriculture fields. So this runoff water, when particularly when flash floods are there, this runoff water which carries huge amount of silt particles, or a better I should say soil particles along with it. These soil particles, this flood water which enters into agriculture fields, it deposits whatever the sediments it has brought. So sometimes the crop which is growing in that agriculture field, that gets completely destroyed, and not only that crop gets destroyed, but the farmer is not able to cultivate the land for maybe many more years, because until and unless he removes these sediments, particularly the sand, he cannot grow the crops. So this is a huge loss. And then flash floods, I should have discussed this before this point. So flash floods, that's also the reason of soil erosion. Why flash floods occur? Because you have destroyed the natural vegetation, so runoff increases. So whenever there is rainfall, in the absence of the land cover, the runoff speed, its velocity gets increased, and it leads to flash floods, particularly in the plains. And these flash floods then ultimately destroy the agricultural lands, destroy the crops, crop gets submerged, and it can even destroy the infrastructure facilities in the cities as well, not only rural areas but in urban areas also. Then pollution of water bodies. So this runoff water and soil particles, these may carry apart from nutrients, some harmful chemicals also, maybe applied pesticides also, they get mixed up in the water. Soluble form of nitrogen, that's also there. Phosphorus attached with the soil particles, that is also carried. So even if there are no harmful chemicals, when this runoff water it enters into water bodies, it increases the nitrogen phosphorus content of that pond water, and then there is huge growth of that aquatic plants, particularly hyacinths, and ultimately the oxygen content in that particular water gets reduced. If oxygen content is reduced, or dissolved oxygen gets reduced, the fish or other aquatic animals may not be there. And you know, fish and aquatic animals, they eat the organic part of that sediments over there in the water. They keep the water clean. So when they don't can't respire because of less oxygen, these aquatic animals they die and water gets polluted. Ultimately, we call this process as eutrophication. Eutrophication process. And because of the flash floods, there is reduced, uh, you know, groundwater recharge also. Because runoff water it runs over the surface. Some of the finer particles they also choke the soil surface. Infiltration gets reduced, and if water does not enter into the soil, then the groundwater recharge will decrease. So these were some of the side effects of soil erosion. Next we will discuss types of soil erosion in another topic. Thank you very much.